Okay, so today we'll be covering many different topics today. So we're going to be covering multi-dimensional lists, copying, libraries, and nested if loops and if statements. Um, for today's joke, I guess I totally didn't copy this lesson from last year. Plagiarism is bad. Um, so I actually didn't copy this lesson from last year, so you don't have to worry. Plagiarism is bad though. So last week we explored most of the main ideas for lists. However, we left out one key essential idea about lists. We covered how you can store any value in a list, from numbers, booleans, strings, to even other lists in dictionaries. And today we'll be covering storing lists within lists, which is what we call multi-dimensional lists. All right. So previously we would only cover like putting in numbers, booleans, and strings into a list, in which they would be called one-dimensional lists since they only contain one dimension. So like let's go back. Let's go to whiteboard here. All right. So I have my whiteboard here. So a one-dimensional list just kind of looks like this. It's like a box, and it just has like values like 1, 2, 3, 4, 5, 6, 7. All right, and this is one dimension. It's like you only index them with like this list with like one dimension here. All right, and there's like list at 0 gets you like here, this value here, and list at 1 gets you this, list at 2 gets you that, and so on and so forth. All right, and that's only one dimension since you only have to specify one index here. Now, once you add a list into a list, you start adding dimensions to the list, and you can access the values within this list contained in another list. So to create a multi-dimensional list, you would initialize your list the same as normal. Then you would just create a list of values within that outermost list, right? So in this example here, two-dimensional list, 1, 2, 3, 4, 5, 6, 7, 8, 9. Another 2D list, 1, 2, 3, 4, 5, 6, 7, 8. Right? So let's bring up idle here. And we can just type in like, if we copy this creates like a 2D list, a two-dimensional list. So we print two-dimensional list here, and it prints out this two-dimensional list. And if you have 3D list, it does another 2D list. It does the same thing. So another 2D list. It prints out the 2D list, and then if I have a 3D list, we can print out a 3D list here, and it prints out this 3D list. All right, and then to access values within this multi-dimensional list, you have to start by in the outermost list and work yourself in. So this list, this like outermost list here, and like let's say in this two-dimensional list here, it contains 3 indexes. Right? This is one list, which is at the 0th index. This is another list at the 1st index, and this is another list at the 2nd index. All right. So first we have to index this whatever list we specify within, like that we have to specify what list we want to get. All right. So if we specify the first list here, we can just do like 2D list, dimensional list at 1. All right, and it outputs this like list here. So let's say 2-dimensional list at 1. It prints this list here. All right, because that's what list we're specifying. And then we have to work yourself in. So let's say we want to get, the middle value. So we want to get 5. We have to specify on top of that middle list here. We have to specify the middle value within this list here. And if we type that in, it gets us this 5 here. All right, and then same thing with another 2D list. So in another 2D list, there's 4. It has this outermost list has a length of 4. Has this list here, which is the 0th index. This second list here, which is the 1st index. This list here, which is the 2nd index. That was a bit confusing. Second index, and here this is the 3rd index. All right. I should have said it much clearer. This is the 1st index since we start counting at 0. All right, and then so if we specify, let's say I want this value here, you specify another 2D list at 2. All right, and it gets us 5 and 6. And now within 5 and 6, you can specify what number you want. So let's say we have another list, another 2D list, and we want to get 2 at 1. It gets us to 6 here. All right, and then within another 3D list, it's a bit more confusing, but it's much more simpler if you just start by working outwards, start outwards and working yourself in. All right, so in a 3D list, if we print it out, it has, it has two actual like index, like two values within this outermost list. This list here and this list here. All right. Now, if we want to get, let's say we want to get this list here, like this 2D list here, we can specify a 3D list at 1, and it outputs this 2D list here with that has a length of 2 as well, with this list at the 0th index and this list at the 1st index. All right. Now let's say we want this first index list here, and we do a 3D list at 1 at 1. It gets us this final list here with 7 and 8. And here we just type in a 3D list, and let's say we want this 8 here, we just do 1 at 1 at 1, and it gets us an 8. All right. Now, there's a nice way of visualizing this. You can kind of imagine it like, let's say we have a 2D list here, all right, and it kind of just looks like, 1, 2, 3, 4, 5, 6, and then 7, 8, 9. And what you can do is you can just like visualize this as like rows and columns. So we kind of can visualize this with one like a grid of like, so with the 0th index, so like this is x's and this is your y's, 0, 1, 2, 0, 1, 2 here. Let's say like this is like I'd start off with like 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So like y at 0 here, like you can just grab this, and like I would grab this list here, and then at y at 1, it grab if you say specify at 1, you'd grab this list here, which would be here, and so on and so forth. Now, could we also like? There's no right or wrong way of visualizing a list. You can't really assign an x and a y value. So if you kind of flip the x and y's here, let's say we did y here and x here, that's also correct because there's actually no proper way of visualizing a list. However, there is a proper way of to like indexing a list. You have to start like you have to index the whatever list you want to specify. So like here, this would be index at 0, 1, and 2. And if we want this list here, we have to index 1 at first, and then we have to index whatever we want within this list to get the individual values. Does that make sense to everyone? Does anyone have questions about that? All right. And to create a multi-dimensional list, you can use the aforementioned method if you want the values. So like this method here, where like you just create like each list individually. However, you can also use for loops, but as we mentioned in the last week's lesson, that's slow. So instead, we will just show you using list comprehension. All right. So in a 2D list, so with list comprehension, this is like the what we're like assigning into the list. So first we start off with a loop. So for I in range to like some x value, all right, we create like this list here, all right, and that creates a list. All right, and within this list, we can use list comprehension to assign each value within this list. So we can like for 0, 0. So in like this list, we create like we assign each value in this list with 0, and like we do 0 for j in range whatever y value is. So it creates in here. It creates a list that contains 0 y times, and then it takes those lists and multiplies it x times within this outermost list. So this list contains x lists that contain y zeros, if that makes sense to everyone. If everyone's heads are completely confused right now, don't worry. But yeah. And then you can do the same thing with 3D lists. You just start working inward. Start by working how many lists you want to make. And then within those lists, you want to have to specify how many lists you want to make in those lists. And then in those lists, you want to specify what values you want to assign it. So you want to create how many lists here. And then within that list, you want to specify how many lists you want to make there. And within that list, you want to specify what values you want in there. And that creates a 3D list. And then a 4D list is a list within a list within a list Yeah, it's a list within a list within a list within a list, I think. Is that right? No. 2D list is a list within a list. A 3D list is a list within a list within a list. And a 4D list is a list within a list within a list within a list within a list. Yeah. So on and so forth. Um, all right, and that, yeah, those that's what a multidimensional is. And a multidimensional list still acts like a normal list, so you can still use the values the previous methods we learned earlier. All right, you can still reassign values in a list. You can find within a list. You can find the length of a list, so on and so forth. All right, now copying lists and dictionaries are a bit different. Now, I want you guys to go try this code. All right, if we go into like idle here, and we create like a new file, and if we save it, so let's save it test.py. All right, let me just save it to my desktop, and we just say test.py, and if we run this here, you know, with this list 1 here, okay, we create this list, all right, and we create list 2 here, but that equals list 1, and then here we add 6 to list 1. If we print list 2, the 6 somehow appears within list 2. But if we do the exact same thing with just numbers, so we create A1, A equals 1, and we just assign B to equal to A, and we add 1 to A, and we print B, B never changes. B just stays the same. And if we do the same with dictionaries, we create a dictionary, all right? And we copy that dictionary to another dictionary, so dictionary 2 equals dictionary 1. And then within that dictionary, dictionary 1, we create a new value. Well, it should be new key, let's say, or actually it just reassigns a value. So let's say dictionary 1, let's say we want to reassign this key to new value. If we print dictionary 2 also gets updated. And you might be thinking, wait, Gordon, how does this work? You know, you're a bit confused. How does these lists and dictionaries update, but this number doesn't update? And that gets to a key topic about copying within Python and programming languages. And this is where we have to differentiate between types of copying, all right? There's something called a shallow copy and a deep copy. Now, those are two words you might get blown away. What are you talking about, Gordon? Why are there two types of copying? Let me explain. So what's going on in the previous method before, what like the examples I showed here, what's going on with the list and dictionary here is something called a shallow copy. So rather than creating like an identical copy with like values, it actually just creates like a reference back to the original list and dictionary. So like it's sort of like it creates like a window to the old original. So if we make any changes to the original, this replica copies that original. And if we make changes to the original, to the copy, then the original also changes. Since, you know, they're kind of just the same thing. Now the real reason behind this is that these variables don't actually store a list or a dictionary. You think I'm crazy. Oh, Gordon, you know, variables don't actually store lists in dictionaries. Well, what happens is these variables store something called a memory address. So everything you create, you know, everything you create in Python or like any programming language is stored in memory. So this is why in like programming contests we have memory limits, since it just limits how much you can store. And you know, these things, like these values, are accessed using these memory addresses. It's sort of like, you know, we have like the mailboxes, right? And everyone has like addresses to like whatever mailbox. Like, if you're given like an address, you know which house to go to, and that's the same thing with programming here. If you have if you create like a variable or whatever, you create like a memory address, and that points to wherever this thing is being stored in your memory. And lists are no exception. So like the variable you assign a list to actually just stores the memory address to the list. It doesn't store the list itself. It just stores, okay, where is this list stored in your memory? And it just points to, okay, the first index is here, the second index is here within memory. All right. And when you try to copy a list, you're not copying the list itself. You're copying the memory address to the other variable. And as such, both variables actually are pointing to the same memory address, modifying the same thing. So let me just visualize this in, let me just draw this out. So let's say we have this variable here. So let's say, actually, let's call this list1. All right. So list1, and it has this memory address, and it points to like, let's say we have like this memory address here, like, and it just has, so memory address is kind of like just represented with like blocks here, right? And we have this memory address like x at ox da 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 da, so like de10 whatever, all right? All right, and this is what list1 is, all right? This is it actually just this memory address. It doesn't actually like store the list itself. It just stores this memory address. And let's say we want to make a list2, all right? And list2 is just going to be list equal list1. Instead of creating like this like list of like 0, 1, 2, 3, 4, instead of copying that to list2, what you're copying is, hey, list1 only stores this value that points to this. Let's just copy that into list2. And now list2 is just equal this memory address here. So if we change this memory address still stays the same, and list2 just looks at it and like, oh, this is where the list is stored. Okay, you know, I see this memory address is just pointing to this list that's been modified. I'm just gonna print that out. And if we modify list2 just modifies this memory address which stores this list there, and as such, they're kind of just like they're intertwined, you know. List2 is just list1 now, and as such, and that's what a shallow copy is. Does anyone have questions about that? Is anyone confused about what the shallow copying memory address thing is? No one has questions. All right. So so rather than like copying this memory address here, what we can do is create a deep copy. And what deep copy is, okay, so if you create like a deep copy, okay, list2 is now a whole separate object. So let's say it's like oxde11 here. Now, list2 is a completely different object, but instead, this memory address now points to a different list that like it has like 1, 2, 3, 4 here as well. And if we modify this list, this memory address is completely separate from this memory address, and as such, they have no pairing. They're like, they modify one, the other one doesn't change. Modify the other one, this one doesn't change, and so on and so forth. So that's where deep copy comes in, which just creates a replica of this it creates a replica of this list. So in order to create like a deep copy of a 1D list, you can just use the index operator to get every value from the beginning to end. All right. So list1, if we just do like list2 and equal list1 with like the double colon, that just creates a new separate list. And if we modify the original list, list2 never changes at all, since this creates like a new list in memory, and it's a whole separate memory address. You can also check, memory addresses within like Python. So let's bring up Python here. Let's say, let's create like a list. So let's list1 equals 1, 2, 3, 4, 5. All right. If we do hex ID at list1, this is where this list is stored in memory. All right. Now if we do list2 equals list1, if we do hex ID list2, this is exactly the same as this other list here. And if we modify list1, so list1.append 6, if we do list2, that's still it's still modified the same place in memory. So that list2 is pretty much the same as list1. There's no difference. Now, if we let's say we do this list2 equals list1 here, all right? List2 equals list1, and this is how you create like a deep copy of a 1D list. If we do this and we check what's the memory address of list2 now, this is a completely separate memory address than what it was before. And now it's storing this in a new place in memory. So that's how you create a deep copy. A deep copy just creates like a whole separate, now it's a whole separate memory address now. Now to create make a deep copy of a multidimensional list, you can't just use the method we did for 1D list. As there are lists within the outermost list, these lists itself now also point to separate places in memory. So like, Let me just go back to my whiteboard. All right. So let's say we have this list here of a 2D list here, 1, 2, and then 3, 4. All right. Now Python doesn't actually store this list in this list. It sounds kind of crazy when I just said before that it's a list within a list, and a list stores another list in itself. But in reality, it doesn't store this list in the other list. Rather, it just says, "Hey, I'm pointing to this memory address that has this list." So in reality, it's like OX DE11 here, and this other memory address OXDE12. All right. And now these actually point to some place in memory saying, hey, this is 1, 1, 2, and this is 3, 4. Now, if we just use the method before of this colon here to create a new list, sure, it creates this outermost list is now completely different. It's a new place in memory. So like, let's say this is OXDE10, all right, and we just say, okay, we want to make a deep replica of this, and we now store it OXDE13, all right. Sure, they're now separate like objects with different lists with like different memory addresses. However, these lists within the list still point to the same place. So if we modified these inner lists, both these lists here will change and they will be exactly the same. So you have to copy, now go inside here and inside each of the lists here and copy them. So this is where we can just use list comprehension here. And let's say within the 2D list 2D, we can copy these lists here and such, so that it creates a new place in memory. It creates a new memory address. All right. So if you go back to let me just close this. Let's go back to Python here, and we just say list 2D equals 1, 2, 3, 4, 5, 6, 7, 8, 9. If we used the method before, so let's say we have copy list 2D equals list 2D at colon. If we do list 2D, if we get the memory address of the first of list 2D, like the first list in list 2D, it gets us this memory address. But if we do the same thing with the first value of copy list 2D at 0, it's the exact same memory address. But list 2D and copy list 2D, their memory addresses are completely separate, but the values inside those lists are the same. So like, let's say hex ID of list 2D. This is one memory address, but then hex ID at copy list 2D. This is a whole completely separate memory address, all right? But the values inside these two lists are the same. So what we have to do instead is copy list 2D equals I for I list 2D. And it goes through each value in list 2D and copies them. And creates them into a whole separate new list, all right? And we do hex ID at copy list 2D at 0. This memory address is now completely separate from this memory address. So now they're now separate, and now you can modify one or the other and get different values. All right. And then with 3D lists, it's the same principle. I'm not going to visualize it since it's going to be a bit confusing. But however, what you have to do is you have to go inside each list within the list, copy them, and just assign it to the new copy. All right. Does anyone have questions about that? Does anyone have questions about memory addresses and copying with lists? Guessing no one has questions. All right, and for dictionaries, there's really no easy way of copying. If you're working with values that are numbers, strings, or booleans, you can just use the .copy method, and it creates a whole new memory address, so it's perfectly fine. So let's say we have dictionary 1 here, all right? So dictionary, let me just copy from the lesson. So we create dictionary 1, and we do dictionary 2 equals dictionary 1.copy. If we look at the memory addresses for dictionary 1, it's going to be separate from the memory address for dictionary 2. These are completely separate memory addresses. So if we modify dictionary 1 with so key 3 equals potato, dictionary 2 stays the same. But if we add a list inside dictionary 1, it still does the idea. It's still it still has the value of a memory address in there, and it's just going to copy that directly. It doesn't copy everything inside that memory address. So let's say we have dictionary 1. So let's say we have, I don't know, list equals 1, 2, 3, 4, 5. All right. And then we do dictionary 2 equals dictionary 1 the copy. If we do hex ID at dictionary 1 dot list at list, this should be exactly the same as dictionary 2 at list. And they're the exact same memory address. So this is still a shallow copy because it didn't go in and completely separate each value of the dictionary. So you're still referencing values from the original. So to make a deeper copy, we'll show you something with a library in Python. And this is a good segue to our next part of our lesson, which is libraries. But before we proceed into libraries, does anyone have questions about copying dictionaries? Or does anyone have questions about memory addresses and copying in general? I'm guessing no one has questions about that. All right. So now within pure vanilla Python, you're pretty restricted on what you can do, you know? This is where libraries come in. These add additional features and functionality that you can help you remove some redundant code. It can help you speed up your code as well as, it just lets you type much less code than you have to. And to get started with libraries, you need to tell your code what libraries you want to use. As these libraries aren't already imported by themselves. You have to specify what you want to import. Now there are two ways of doing this. So one way to import libraries is just by saying at the beginning of the code, import whatever library, and this will import the library. And to use the functions or any items from the library, you have to type out the library name, followed by a period, followed by what you want to use. So library name dot whatever. So let's say we have, let's say we use the random library, right? And we do import random, and we want to make a random integer, all right? We have to do random.randint after we put import random. All right, and let's say this library is absurdly long or has some confusing name. Rather than just using the library name every single time, you can rename it to something else using the keyword as. So let's say we're importing random, all right? So let's say we import random, all right? And let's say we want to make a random integer, so random randint, and say up to 10. Random randint 1 to 10, all right? And creates a random number to 2, creates a random number. Let's say we don't want to be typing random every single time. Let's say we just want to type R. We can just do import random as R, and then do r.randint at 10. r.randint 1 to 10. And this does the exact same thing as before, but we just shorten random to as R. Now, if you don't want to type out the full name of the library at all, and you just want to import, what specific functions or items from this library, what you can do is just do from random, from the library name, and import whatever you want. So let's say we only just want to use randint here. You do from random, import randint. And here, you can just, instead of typing random dot whatever or whatever dot whatever, you can just specify the function or item and just do directly, and it just treats it as like it's normally in Python. Now, if you want to import multiple, you just separate, like, let's say from random import random, or like let's say from random import random and random and like choice. All right. This would import multiple functions, so that it would import random and choice from the random library. But if you're just importing one, you don't have to specify a comma. Now, when you call the function, you can just call it directly. So I showed earlier without putting the name before it, followed by a period. And then you can also import all the functions items instead of importing them individually. So this can be just done by using star. So like let's say we want to import everything from random. We do from random import star, and that imports everything from random. All right. Now, if you decide to use from import method, you might encounter some issues if you try to import functions or items that share the same name. So let's say we have library 1 that has this function that's called function, all right? And then we have another library that also has a function called function. If you call function, if you import both of them and you call function, there's going to be some conflict there. So rather than just having this conflict here, you can use the as keyword, and instead of importing this function as the name function, you can import it as another name. So let's say I don't want to be let's say there's a conflict with random, all right? Let's say I already have a random function. Instead, you can do import random as ri. And instead of saying random, now you can say ri at 110, and it does the exact same thing as before. All right? And now some of the libraries that come in Python are available at this documentation here. If I click this, it will bring me to all the possible all the libraries here in the Python standard library. So like some things like datetime, zone info, calendar, heap queue, copy, pprint, numbers, cmath, os.path, yada yada yada. So many libraries to choose from, and these are all pre-installed on Python, so you don't have to go out and install these libraries. Now, you can also use external libraries. Now, external libraries, these libraries you have to download them yourselves, and usually you have to do it through your terminal or command prompt with something called pip. We won't be covering too much about installing external libraries since they won't be used in competitive programming contests. However, you can use the libraries that come with Python in competitive programming contests. But if you want to use external libraries, you'd have to go out and learn how to install it. So like, let's say we want to learn how to install Pygame. So pip, you can search up like Pygame, and it should bring up like this place called like PyPy, and it will give you like the command to install like this library, right? So like pip install Pygame. Now this is one of the things you'll have to do in grade 11 comp sci is ICS 3U is learn how to you have to install Pygame. So you do pip install Pygame in your terminal, or like let's say we do Flask. We'll search up the library Flask. You do pip install Flask, and that's how you install this library here. All right, using pip. Now I'm going back to the copying lesson. Well, some of the libraries we'll cover today are copy and pprint. So pretty print. There'll be more libraries we'll cover in the future. So going back to the copying lesson, I mentioned there was an easy way to make a deep copy. This is where the copy library comes in. So the copy library has two functions come with it. Copy, which just does a shallow copy of the object specified, and deep copy, which makes a deep copy of the object specified. So this is how the example they're used. So like, let's say we create let's say import copy. Now we do random object equals 1, 2, 3, 4, 5. All right, and then we do a shallow copy of this random object. So we do copy.copy, rand object, and then we do a deep copy of this object. So copy.deep copy random object. So we do random object at 3.append 6. If we look at a shallow copy, this is a shallow copy. So it will add the 6 into this the shallow copy as well, since they're the same memory address. But if you look at deep copy, it created a deep copy. So the 6 is not added. And you can do the same thing with you can use deep copy here with dictionaries as well. But with deep copies, it's more time. It uses more memory and uses more time. So your mileage may vary if you want to use deep copy. Onto pprint. So it's called pretty print. You can use this to like cleanly print out a multidimensional list or dictionary. So let's say we have this very large list. If you printed it normally, it may be hard to read. But if you use preprint on the other hand, it will cleanly print them in different rows. So let's say we import pprint, all right? And do a 2D list. So let's create a 2D list equals 0 for k in range 10, and then for I in range 10. All right. If we just print this normally, so let's say we print 2D list, this is going to be hard to read. You don't know which list corresponds with what list and so on and so forth. But if we use pprint here, so the pprint.pprint at 2D list, it will nicely, cleanly print every single list in separate rows. All right, and that's what pprint does. Now, the last thing I want to cover today is something called nested loops and if statements. And essentially what they are is it's just a loop or an if statement contained within each other. So like multi-dimensional lists, you start by working on the outermost loop and you're working yourself in. So you also need to keep track of the indentation as it's important to Python to specify how deep into the loop or if statement you are. So like for for loops, you need to have the variable to specify, and for for loops, you need to have the variables within each nested for loop different. So like you can't have for I in range 10 and also do for I in range 10 in here. This won't work. This will just cause a bunch of errors. Sorta. It just gets it sort of gets really messy having to deal with things. Well, it gets messy once you get into like different programming languages. For Python, it's a bit nicer to work with, but when you get into different programming languages, it's a complete mess. So we just recommend having different variables to specify different things in your nested for loops. All right, and that's it for nested for loops and if statements. So here's some examples. So like you can have like this for loop here and another for loop, and that would just print out. So like for print for I in range 5, for j in range 5. If you print out I and j, it prints out 0, 0, 0. It starts with zeros, and then in this case it goes 0, 1, 2, 3, 4, and then ones 1, 2, 3, 4, 0, 1, 2, 3, 4, 2, so on and so forth. And that's what nested for loop is. And then with like nested if statements, like let's say x equals true, y equals true. All right, and do if y, print both x and y are true. And we print out, it prints both x and y. So it starts off by going from the beginning. So if x is true, then it goes on, proceeds into this loop, into this if statement. If y is true, proceeds on here and says it print both x and y. And that's essentially what nested for loops and if statements are. It's pretty much, you can cram if statements inside another if statement, inside another if statement, and it like allows you to check multiple cases. And it's kind of nice and clean sometimes, but don't try to use nested if statements if you can easily just pack into like one statement. Don't go like if x and then if y. This wasn't really a good example. Whoops. This wasn't really a good example, since, you can just simplify it as if x and y, but let's say like we had if x and then we had like two cases like if y or like if z and so on and so forth, then that'd probably be a better idea. But, yeah, those are what nested if statements and for loops are. And yeah, I guess this is the end of our lesson for today. Since last week I gave out a lot of questions for you guys to deal with, this week I will give you guys fewer questions to work on. And also, this week is a holiday. Go relax. We've had 1 month of school already. Go relax. Don't stress about too much about comp sci. So I gave you guys like 5 questions to work on. Go ahead and try them if you want. If you don't want, that's also fine. But yeah. Did anyone have questions about today's lesson? Does anyone have questions, I guess? What was this lesson confusing for anyone? Or does anyone have like comments, concerns about the lesson for today? It's almost 6, so I guess.
Could you explain what list comprehension is? You don't mind?
Oh yeah, so going back to the previous week lesson. So let me just get that up. So uh, let me just get the link for it. All right. Let me just get the link for week 2. So what list comprehension is, it's another way of just simply creating a list, I guess. You know, let me go back to like essentially you can break it down in a way to like easily create a list. So like let's say we have list here, right? This list 1 here, right? And we want to create a list full of 10 zeros, all right? You could just create like a for loop. Oh, whoops, that's not what I meant to do. You could just create like a list of like a for loop, all right? Like create this list here for I in range 10, and you do list 1 dot append 0, right? You could do this and then print list 1, and that creates 10 zeros. But with dot append, it's a bit slow, and it like it uses a lot of memory. So rather than doing that, we can just do like list 1 equals like 0 for I in range 10 for I in range 10. All right? And what this essentially does is, okay, we create this list, we create you know, for I in range 10, add for I like for this loop, add this into this list. And if we print list 1, it creates 10 zeros in this list. All right? So it adds this value here within it for like the number of times this loops. Does that make sense?
Yeah, I get it now.
Yeah. So that's what list comprehension is. And pretty much you can just simplify creating a list into just one compact space. And it also works with let's say we have like multiple values for like an input. So for I in input dot split, all right? So this creates a list, right? Like input dot split from last week's lesson, right?
Yeah.
So we can specify like in this loop, like because this is kind of works like a loop, and this is the part that goes inside the loop. Like how here like a list dot append at 0, right?
Yeah.
This is pretty much just like, oh hey, like this is what goes inside the loop, and it just does like the list dot append. This is what we're appending in here. The like that. This is pretty much what this does. It just takes this, and it's just this middle part. This like part here in the parentheses. So if we type this out and we have the input, so let's say we have 1, 10, 2, 3. And we type out list 1, it gives us 1, 10, 2, and 3. So yeah, so this is what this part here. It's pretty much just it takes like the list and dot append, and it's just this middle part in the parentheses here. So does that make sense to you?
Oh.
What list comprehension is?
Yeah, I get it.
All right. Does anyone else have questions? It's almost 6, and it's almost time to go. So does anyone have questions about this? Going once. Going twice. Going 3 times. All right. This meeting is adjourned. You guys can go and relax. Go do the 5 questions. Go do whatever you want. Go do your homework. Have a nice day.